Okay, so today we're going to talk about arcs and chords. Alright, so we have a theorem that says in a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So if AB, this chord right here, is congruent to CD, the chord over here, then that means arc AB would be equal to arc CD. Alright, another theorem we have is that a polygon is inscribed in a circle if each of its vertices lie on the circle. So in other words, I have a quadrilateral here, a four-sided figure, and I see that I've got all the vertices are on the circle. So L, K, N, and M. So therefore, K, L, M, N is inscribed in the polygon because of all its vertices are on circle J. Alright, a circle is circumscribed about a polygon if the circle contains all the vertices of the polygon. So circle J is circumscribed about the polygon because it contains all the vertices of the polygon. Alright, so in circle O, find the indicated measures. Well, if you will notice, all of the sides are the same, and the sides of this quadrilateral, okay, I guess this is a square, or a rhombus. We don't know that these are 90. Alright, I see that they're all the same. Well, if the chords, which is what these are, I have a vertex here and a vertex here. Alright, if the chords are the same, then that means all of the arcs are the same. Well, since there are four sides, then all I have to do is take 360 and divide that by 4. That'll tell me how much each little spot is. So that gives me 90 degrees. So every single side is 90. So this side is 90, this side is 90, this side's 90, and this side is 90. Alright, so CD, that would be this arc right here, is 90 degrees. Alright, arc ABC, well if I start here, alright, let me get a highlighter here. If I start here at A, and I go from A to B to C, that would give me this part and this part. We'll add those two together, and that gives me 180. Alright, ABD, so that means I start here, I come around that side, this side all the way to the D. Alright, so I've got A, B, D, so that would be 90 times 3, which would be 270. And then BAD, so I start at B, go to A and D, so that covers 2 of these, so 90 times 2 is 180 degrees. Alright, this time I have a three-sided figure in which all three sides are the same. So again, 360 all the way around. I'll divide that by 3 because I have 3 equal sides. Alright, so that means every single piece is 120 degrees. So RS is 120, ST is 120, TR is 120. So RS, 120. RST, that's 2 of those, so that would be 240 degrees. RT, that's just one side, 120 degrees. And TRS, that would cover this part right here. That's 2 of those pieces, so that would be 240 degrees. Alright, so now I have a 5-sided figure. All 5 sides are equal. So I'll take 360 and divide that by 5. So that means every piece is 72 degrees. So this side is 72 degrees, 72 degrees, every little part. And you don't have to label these every single time, but you know, sometimes it's helpful. It'll be helpful later on when they're different. Alright, so WX, that would be 72 degrees. W, X, Y. That's 2 of those, so that would be 144 degrees. W, V, Y. So from here all the way to here, that would be 3 of those pieces, which is 216 degrees. And YWZ. So YWZ, which is 4 of those pieces, which would be 288 degrees. Make sure that you go in order, too. You don't want to go Y, W, and then Z. I mean, that makes no sense. So make sure you do Y, next one is W, and then the next one I come in contact with is Z. All right. Now we have a figure where 2 sides are the same, but this side is not, right? But I do know that this side is 9x, right? And it's the same as this one, so this is also 9x. And then I have this little piece down here, so that covers all 3 sides, right? So I've got 9x and 9x, that would be 18x, plus 2x would be 20x. And I know that that's equal to 360 degrees, all the way around, right? So I divide by the 20, so I can figure out what x is. That makes x equal to 18. And then I can plug in for x to see what each of these arcs are worth. So 9 times 18 would give us 162. All right. All right, so this is 162 over here. Well, I know that this arc is the same, so therefore this would be 162. And then DE would be 2 times 18, which would give us 36 degrees. And I like to label it like right off the bat. I know that over here you answer the questions and then you've already done the work, so that's the nice thing about doing that. So you've got DF, so DF, well that's 36 degrees, we just figured that out. DE is 162. FE is 162. And DFE, that means I would have to take the 162, because that's this part right here, and add that to this part, which is 36. And when I do that, DFE, that gets me 198 degrees. All right, circle O. So in this case, they give me BC up here, that's 80. And then I know that these 2 side pieces are the same, all right? And I do know this side because this is obviously my diameter because it goes straight across through my center. So that means that this whole half circle is 180. Remember, if you do a 180, you just flip around. So this is 180 and this is 80. Well, that leaves these 2 pieces left over. So if you think about it, if I take 360 and I subtract 180 and then I subtract 80, that gives me 100 degrees. So there's 100 degrees left over for this part right here and this part right here. Well, I know that those parts are equal because I've got the congruency marks on my page. So therefore, if I just take and divide 100 by 2, that tells me that each piece is 50. So I've got CD is 50. All right. BAD, so that would be this whole half, which is 180, plus the 50. That's going to give me 230 degrees. Then I've got ABC, so that would be the 80 and the 50, which would give me 130 degrees. And then CAD, so CAD would cover all of this part right here. So that would give me 310 degrees total. All right, now I have a figure where they give me this side, which is 100 degrees, and then I have 4 sides that are the same. So if I take the 100 off of the 360, that leaves me with 260 left over for the rest of this circle. So there are 4 equal parts, so I divide that by 4, which gives me 65 degrees. So every one of these parts that equal are 65 degrees. So MN is 65. MRQ, that would be these 2 pieces. I add them together, 65 and 65 would give me 130 degrees. RQP would be the 100 and the 65. Well, that gives me 165. And then MNR, which would be everything but the 65. So that would give me 295. And sometimes an easier way to do it, instead of adding up every single piece, because there are 1, 2, 3, 4 pieces out of 5 on here, instead of adding them up and taking them away from 360, you can always, or not taking them away, but just adding them up, you can always take the one piece that's left over and subtract it from 360, and that leaves you with all of the rest of it. So that's just a second way to do that, if you so choose. Alright, so now I have 150 on this side, and then I have 3 equal pieces left over. So I'm going to take the 360 and subtract 150. That leaves me with 210 degrees to go among these 3 pieces. So I divide that into 3 equal pieces, and every piece is 70 degrees. So when I'm finding WX, WX would be 70. XYZ would be this piece that's 70 and this piece that's 70, so that gives me 140 degrees. WZY, so that'd be the 150 and the 70, that would give me 220 degrees. And WXZ would be everything but the 150. So again, I could take 360 and subtract 150, and that would leave me with all of the rest of this. Or you can just add 70, 70, 70, and that gives you 210 degrees. All right, last one of these kind. So if you're not careful, you're going to think that this piece is equal to all of these, but it's not, because it doesn't have that congruency marker there. So I know that there's 360 total, and I know that this piece is 65. So if I take the 360 and subtract the 65, that gives me 295 degrees left between these 5 equal pieces. So I will divide by 5. So every one of those pieces is 59 degrees. And again, you don't have to sit here and write these down. I mean, I think you can remember that they're 59 degrees, but, you know, I like to have them up here. So DE, from here to here, that's 59 degrees. All right, BD, from here to here, that's 2 pieces of the 59, so that'd be 118 degrees. AE, so I've got, and I'm going to point this out because I also was wondering which way I should go. If it's AE, I can go this way or I can go this way. But remember that if it's over 180, you have to label it with 3 letters instead of 2. So if you have the option of going all the way around, which is way more than in 180, or coming the shorter distance, you need to go the shorter distance. So 65 and 59, that's going to give me 124 degrees. And then ABE, ABE is everything except for these 2 pieces. So that would give me 236 degrees. All right, so in a circle, if a diameter or radius is perpendicular to a chord, so here's my diameter, and I'm perpendicular to chord XZ, and I know that because there's a 90-degree symbol there, then it bisects the chord and its arc. So in other words, this would be equal to this, and this piece would be equal to this piece. In a circle or in congruent circles, two chords are congruent if and only if they are equidistant from each other. So in other words, AB would be congruent to CD if and only if EG, this part, is congruent to FG. So if these two are equal, then that means that this chord is equal to this chord. And these would form 90-degree angles right there. All right, so in circle A, they tell me that PQ is 33. And I like to label everything before we even answer questions. So PQ, that whole thing, PQ is 33. So I'm not going to write 33 on here because there's so many lines. All right, MB, this little arc right here, is 38. And then they tell me that AD, the piece from the center to that chord, is congruent to AE. So this is congruent to this. And we know that if those are congruent, then the chords are congruent. So since PQ is 33, that means MN is also 33. And then I also know that they bisect. So if this is 38, that means BN also has to be 38. And since the arcs are the same, because the chords are the same, this is 38, and this is 38. And then I know that since MN is 33 and PQ is 33, if I half that, I get each little piece right here. So like MD would be 16.5 along with this part right here. And same thing over here on PQ. So let's see if we can answer these questions given, kind of what we've already labeled. So I've got MD, so that's from here to here. Well, we've already decided that's half of the 33, so that would be 16.5. All right, EQ, so from here to here, well, I know that that is also 16.5. All right, MN, we've already established that that's the same thing as PQ, which was 33. PE, so from here to here, well, we've already established that that is also 16.5. All right, PC, this arc from here to the middle, we've already established is 38 degrees. BN, also 38 degrees. PQ, so that would be this whole thing. Well, all I have to do is add up these pieces, right? So 38 and 38 would give me 76 degrees. All right, CP, so from here to here, that would be 38 degrees. And CQ, 38 degrees. So as you can see, if you go ahead and label everything, when you start filling these in, then you're not looking all over your graph half the time because you've already assessed the situation. So that's my advice, is to come in here, label what you know, and then go back to the questions. It's much easier that way. All right, circle H. We know that FG is 86. Okay, so this whole thing, 86. And DE, this chord, is 22. And they tell us that AJ is congruent to AK. When those are congruent, all right, it bisects the chord and the arc on either side, and they are equal. So that means that this side is also 86. And then if I cut that in half, that makes this part 43 and this part 43. Same thing over here. 43, 43. And then I also know that this whole chord was 22, which means this part's 11, this part's 11. This is also congruent because of these two pieces being congruent. So you've got 11 and 11. So now we've labeled every single thing that we know. Let's go to our questions. DJ, and I don't mean like disc jockey. All right, DJ, well, that's 11. GK, that's 11. FG, that's the whole thing, so that would be 22. EJ, 11. The measure of arc DE, so D all the way to E, well, we know that that's 86 degrees. All right, CF, 43 degrees. BD, 43 degrees. CG, 43 degrees. And BE, 43 degrees. Make sure on your arc measures that you're using degrees. On your segment lengths, you don't have degrees. All right? All right. If CD is 24 and BC is 45, find AD. So that would be this part right here. Well, I know that this is a chord and this is perpendicular, so therefore it bisects these into two equal pieces. So if this side's 45, that means this side is 45. And then I know that I have a right triangle here. I've got a leg, my hypotenuse, and then another leg. So anytime you have a right triangle and you're trying to figure out one side of that, you can use the Pythagorean theorem. So remember, that's your hypotenuse squared, which is equal to one of your legs squared plus your other leg squared. All right, so I square root that. So that means that AD, which is my hypotenuse, is equal to 51. And just plug that in your calculator, all right? It gives you the answer. All right, BK is 39, and AB is 72. So the whole thing is 72. So that means if I want just this piece right here, I just half that, right? So half of 72 would be 36. And they want me to find KM, which is this part right here. Well, if you notice, you have a right triangle right here. This would be a leg. This is your hypotenuse because it's across from your 90-degree angle. And then the part you're wanting to find is a leg. So you have hypotenuse squared is equal to my leg squared plus the other leg squared that I don't know. Okay? So all I have to do is subtract the 36 squared. So now I have B squared is equal to 39 squared minus 36 squared, square root, and I know that MK is equal to 15. All right. So the radius of circle Q is 65. So that means from here to here is 65. From the center to the side, 65. And then I know that MP, so this chord all the way across, is 120. So since this is perpendicular, I know this cuts into equal pieces. So I half the 120, that gives me 60. And if you look at this, you might be thinking, well, I don't think that I have enough information to find in R, so it would be this piece right here. Well, let's think about this. I know that my radius is 65, so I can draw a radius from anywhere. So in other words, I can draw a radius out here to P, and all of a sudden now I have this right triangle because I already know that this is perpendicular. So this is 65 because that's my radius. And if I find this piece right here, from here to here, then I can take that away from the whole thing, and that will give me this part. So this is my hypotenuse. This is a leg. This is the other leg. And I'm going to kill two birds with one stone. So let's just reiterate here. If you're finding the hypotenuse, then you would take the square root of one leg squared plus the other leg squared. If you're trying to find a leg, you take the square root of your hypotenuse squared minus the leg you have squared. So just like we did on this one, I was trying to find a leg, so I took my hypotenuse squared minus the leg I had squared, and I square rooted that. On this one, we were trying to find the hypotenuse, so I squared both legs and added them together. So when you're finding a leg, you use a minus, and when you're finding the hypotenuse, you use a plus. All right? So I know that QR, which is this leg over here, is equal to the square root of my hypotenuse squared minus 60 squared. So I know that that little piece is equal to 25. So I know that this whole thing is 65. We already talked about that. That's the radius. So if I take off the 25, that's going to leave me with NR. So NR is equal to 65 minus 25, which is 40. And if you don't feel comfortable with skipping those steps, then write it down like we normally do and just work it out. All right? There's nothing wrong with that, and that's perfectly fine. All right? All right, we're supposed to find YZ. So I know that my radius is 14, and I can draw a line all the way out here, and I know that it's 14, and say, okay, it's perpendicular. All right? And they tell me that this is 120, right? Well, if you think about this, if you have this shape right here, I know that this is also 120, and it is bisected by this perpendicular bisector. So that means that this angle is going to be 60, and this angle is 60. Well, I'm trying to find YZ, which is the whole thing. But if I know half of it, let's say I know this part right here, then I can double it to get the whole thing. Well, we're going to have to use a little bit of our trig functions here because I have 60 right here. All right? So you can think of this two ways. If you will recall, in a 30, 60, 90, this is 60, so this would have to be 30. I know that I can either use sine, cosine, tangent, or I can think about the legs of my hypotenuse. Okay? So I know that the 60 side would be 2 times the length of my 30 side. Okay? And then my hypotenuse is the square root of 3 times my, I think I said that backwards. All right, so let's just skip that. And we're just going to do it with the sign. That way I don't confuse you. All right, so if I'm looking at this angle, this side would be opposite. This side would be hypotenuse. So that means I would have to use sine. So sine of the angle 60 is equal to opposite over hypotenuse. So I would multiply by 14. And if I plug that in, it's going to tell me that x is 7 square roots of 3. So this little piece is 7 square roots of 3, but I would have to double that. Sorry, I wrote that wrong. I have to double it. So that would give me 14 square roots of 3. All right. All right, suppose a chord is 40 inches long. All right, so we need a circle. I don't have my little, oh yeah, I do. So draw yourself a circle. And we have a chord. It is 40 inches long. And it's 21 inches from the center. So if this is the center, this would be 21. They want us to find the length of the radius. All right, well, I know that, let's say that this is perpendicular. That means that this part would be 20 and this part would be 20. And the radius extends from the center to any point on the circle. So now all I need to know is this radius right here, which would also be my hypotenuse. So when finding the hypotenuse, you take the square root of your legs squared and added together. So if I do that, I get 29, and our unit of measure is inches. All right, find the length of a chord. So again, we need another circle. All right, it's 9 inches from the center. So we have a chord 9 inches from the center. And we have a radius of 41. Always draw your radius to try and make that triangle. So this is perpendicular. We can figure out this part right here. So we're trying to find the length of the chord. Well, if we find half the chord, then we can double it to get the whole thing. So we're finding a leg. So I will take my hypotenuse squared minus the leg that I have squared, and that gives me 40. But I have to double that, which gives me 80, and our unit of measure is inches. All right, last one. The diameter of a circle, so I need a circle again. The diameter of a circle is 90 centimeters. So we'll say this is the center here. And a chord is 72 centimeters long. So we have a chord over here, 72 centimeters long. Find the distance between the chord and the center of the circle. So I need this right here. So let's say this bisects perpendicular. Well, I know that that means that this little part is 36, because that'd be half of 72. And then I also know that if I take half the diameter, that means that the radius would be 45. Well, I can draw that to this corner to make a triangle, so that would be 45. And then I can find this leg, which would be the distance. So I'm finding a leg, which means I take the hypotenuse squared minus the leg squared. And that gives me 27, and our unit of measure is centimeters.